Alright, today we are going to derive an expression from the standard gravity of the log as a function. So we'll just do SG of the log as a function of h over r. So our first step, we're just going to draw a log here. Look like that. Yeah, that's my log. And then our next step is we will draw the radius here, which we'll label as r. And then we'll draw the water level here. And then the distance between the water level and the top of the log here, we're going to label as h. And then we'll also draw the length here. So we'll go from this end to that end. That is going to be L. And then we know that SG is equal to the density of the log over the density of the water. That's how we'll find the standard gravity. So, from Newton's law, we know that force is equal to mass times acceleration. In this case, the log is not moving, which means A is equal to 0. But we also know this is equal to F of B minus F of G, where the B is buoyancy. I might be spelling it wrong. I think I am. Just erase that. And then F of G is gravity. And then the buoyancy force is the weight of the fluid displaced. So in this case, what we're going to do is we'll rewrite it as FB is equal to FG. And then we also know W is equal to mg, and density is equal to m over v. So in this case, we're going to solve for the mass. So the mass is equal to the density times the volume. Now we're going to take this and plug it back in to the mass there. So in this case, what we'll end up coming up with is FB is equal, I'm gonna make sure the paper's straight. FB is equal to the density of water times the area times the length times gravity. Now this is the part submerged by water, and then this is gravity, and then this is the length. And then for FG, we have density of the log times the area times the length times gravity. And then we know the area of a cylinder is equal to pi r squared. So we will rewrite this equation as Fg is equal to the density of the log times the area, which is pi r squared, times length times the gravity. And then what we're going to do is we're going to substitute these two in for FB and FG. So we will have the density of water times area times length times gravity is equal to the density of the log times pi r squared times the length times gravity. Then what we're going to do is we have like terms on each side, so we're going to cancel those out. So both gravities cancel and the lengths cancel. So what we're left over with is the density of the water and the area on the left, and the density of the log and the area of that log on the right. So we'll rewrite that as the density of the water times the area is equal to the density of the log times pi r squared. So the next thing we'll do, I'm going to rewrite the log here so we have a better look at it. So there is the front of the log, so we're going to have right there is our radius. And we'll go back over here. This is our water level, and this is our h, and then our distance here is actually going to be r minus h. So the next step, what we want to do, I have to reset this up, is we're going to be looking for the triangle, looking for figuring out what the r is. So we know a squared plus b squared equals c squared. So when we will rewrite that, it ends up being x squared plus r minus h squared equals r squared. Now what we want to do is we want to solve for the x. So this is going to end up being x is equal to the square root of r squared minus r minus h squared. Now what we need to do is we need to expand this r minus h squared out. So what we'll end up getting, and I'm going to include this negative sign, is negative r squared plus 2rh minus h squared. Now what x is going to end up equaling is x is equal to the square root of 2rh minus h squared. What happens is these r squares, actually this subtracts and they end up going away. So the next part is we want to find the area of a triangle, which I am going to grab another sheet of paper because I am running out of room. I'm going to move this one over here.